So within interval problems, sometimes we're interested in V average over multiple intervals. Now let's consider, what are all the ways to find V average? Yep. D over T. What's another way? Go. VI plus VF over 2. Okay. Now, this one has a rule. The rule is if what's true? It deals with how the object gets from the speed it starts with, VI, to the speed it ends with, VF. It has to transfer, it has to get from one speed to the other in a particular way for that equation to work. Yeah. Uniform what? Uniform acceleration. Now, if you have uniform acceleration, that works. Now, if you're in one interval and another interval, how do you know that the interval changed? The acceleration changed. Is that uniform acceleration? No. So this really only works within one interval. Missed an R in there. Boy, that's terrible handwriting. Sorry. So if you're in first gear in your car, you have certain acceleration, and you would go from one speed to another. You want to know your average speed in first gear? That equation's fine. But if you take your car out of gear and you shove it into second gear, and you go from one speed to another, if you try and take the VI from first gear and the VF from second gear and try and find the V average over that whole time, guess what? Doesn't work. You wouldn't have uniform acceleration between first and second gear. This only finds you V average across one. So you would have to do this. You'd have to know the distance you traveled first and second gear. Now that always brings up another question. Let's see if you ask it. Yeah. This is, as we're dealing with interval problems yet, we're not combining the two yet to have vector and interval problems. We're doing interval problems that are still along straight lines. So we're doing 1D. What if you wanted to know the average speed over both first and second gear, and you didn't know the total distance and total time? That's always the question that comes up. Will that work? Could you use this to find V average in first gear? For the benefit of everybody online. Could you use that to find the V average in first gear? Sure. Could you use that again to find the V average in second gear? And then what you're really asking is, can I make a new equation? And that new equation be V average in one interval plus V average in the second interval. Can I just mathematically average the two together and get the average? Well, let me ask you this question. Let's say you were on the freeway and you went 50 miles an hour for an hour. And then You realized that you're obnoxious going 50 miles an hour on the freeway, so you decided to go 70 miles an hour, like everybody else. And you did that for an hour. Is your average speed 60? You went 50 miles an hour for an hour, you went 70 miles an hour for an hour. Is your average speed 60? Yeah. So that would seem to work, right? 50 plus 70 divided by 2, 60. Now, if you went 50 miles an hour for an hour, and then you went 70 miles an hour for 5 minutes, have you averaged 60 miles an hour? No. Your average speed would be a lot closer to 50 because you spent so much time going 50, didn't you? So this equation works sometimes. When does this equation work? When the time that you spent doing both speeds is equal. So this equation also has a rule. It's if the time spent in interval 1 equals the time spent in interval 2. And for that matter, if it was 4 or 5 or 50 intervals, as long as you spent the same amount of time in every interval, you could average all of those speeds. Now let's say that you drove to Fort Collins and you wanted to know your average speed. One way to do it would be to have a buddy with you, and every 15 seconds your buddy could say, "How fast are you going?" And you could look down and tell him, 51. And 15 seconds later, "How fast are you going?" 52. And then 15 seconds later, "How fast are you going?" 51. 15 seconds later, "How fast are you going?" And if you did that every 15 seconds, because that would be a pretty good measure of how fast you're going, every 15 seconds, you could take all those speeds and average them together with all the different data points you have, and you would have your average speed. But that'd be annoying, because you need to know your average speed for equal amounts of time, so you'd have to read your speed all the time to be able to do that. Or every time you accelerated, you could look at your speed and look at your final speed and calculate your average speed for that interval, right? And then calculate the distance and time and add it all up. Ooh, that'd be brutal. If you really want to know your average speed to Fort Collins, wouldn't you just at the end go, I drove about 67 miles, and it took about 1.3 hours, so my average speed was whatever 67 divided by 1.3 is? This equation to find V average has no rules. It works all the time. We like equations that are free from rules. These other ways of finding average speed have uses, and sometimes they're the only way we can find average speed, but because they have rules, we have to be careful with them. Be sure you don't use one of these second two ways to find average speed in a time where it wouldn't work. Now, sometimes, in order to find distance and time over multiple intervals, what you will need to do is find the distance in each interval and add it all up, and the time in each interval and add it all up. And if you do that, you have something we call d sub t and t sub t, total distance and total time. And then you can just divide total distance by total time, and you've got the average speed over multiple intervals. So be careful. When you're looking for an average speed over lots of different kinds of motion, the simplest, most effective way to do it is just to know the total distance and total time. Other ways work if you've got the data for those other ways.